Hello, I'm Gabriel Vasile, and together with my colleague Marco Congedo, I present today the paper entitled Comparative Analysis of ICA-based Incoherent Target Decomposition for PolSAR Data. So my talk will start by introducing the independent component analysis framework for PolSAR data. And in order to do that, we have the following decomposition. Given a certain collection of observation data, which can be data from a local neighborhood or a certain class which has been produced by a certain classification algorithm, we can decompose this observation data as the product between a mixing matrix and sources. So in the case of monostatic PolSAR, then the input data is a 3-element target vector, and the mixing matrix will be a 3x3 complex matrix. Now, if it fix the energies of the sources to unitary variances, then the total energy is transferred to the mixing matrix, and the columns of this matrix will be independent pulsar backscattering mechanisms. And the importance of these mechanisms are obtained as the L2 norm of each column. In terms of the ICA algorithm, we have selected the complex fast ICA, which will achieve independence by maximizing the logarithm contrast function, as it has been proposed in our paper from 2015. Now, in this framework, there are some issues which have been solved and some still open issues. And in terms of the solved issues, the first one is the fact that by using the ICA, the second and the third backscattering mechanisms are unconstrained by orthogonality. And after deriving the mixing matrix and the backscattering mechanisms, then we can apply the 2Z target scattering vector model in order to achieve robustness with respect to the rotation around the line of sight and any change of polarization basis. When deriving the ICA-based mixing matrix, we do not have an independent clutter model which is assumed. And as the algorithm emphasizes non-Gaussianity by taking into account higher order statistics. Also, we have shown that this method behaves very well with Gaussian clutter, and it requires a number of samples which is comparable to the standard principal component analysis. We have also shown that it contains different information by relaxing the unfeasible regions from the H-alpha plane. This has been illustrated on the 4 bands on the Mer de Glace Glacier, which are the transitions between the clean and the dirty ice. Now, 2 open issues are still in progress, namely how to apply speckle filtering within a local sliding neighborhood, and how can we obtain a classification in this space of mixing matrices in order to apply our algorithm as a global approach. Before addressing these 2 issues, I show some results on French Guiana at P-band airborne data, which was acquired in the framework of ICA TropiSAR campaign. And we have a result of adaptive filter, MMSC filter, and a boxcar filter. And here is the polarimetric whitening filter obtained with the fixed point estimator. We can clearly observe that spatial resolution is a lot better preserved by the adaptive filter. And this is confirmed if we take a look at the 2Z parameters, which are computed using these filters. And also it can be observed that if we plot these parameters on the Poincare spheres, we have to the left the one which corresponds to the boxcar, and to the right the one which corresponds to the MMSE. We can notice that when you use a specially adapted filter, we perform less filtering and the variance of the data is increasing. Now we shall address the new topics which we present today. So the problem formulation is how to exploit the space of ICA mixing matrices, as these matrices do not exhibit any interesting mathematical property which can be exploited later on in a classification algorithm, as there is no established metric for a general linear group of mixing matrices. So the solution which we have proposed is to use the polar decomposition coupled with the Riemannian information geometry. So what is firstly the polar decomposition? As it was introduced for PolSAR data by Suiris and Tison in 2017, an initial 2x2 scattering matrix can be decomposed as a product between two matrices. The first one is the unitary matrix U, and the second one is the Hermitian factor P. Now, this decomposition is similar to the complex polar, to the polar representation of complex numbers. The U unitary matrix is a rotation, and the Hermitian factor, it's similar to the modulus. So what is interesting to see is that U is unique if our matrix is a full rank. And in our case, the matrix is a full rank as due to the noise, thermal noise, speckle noise, which are present in the data. So this matrix will always be invertible. Now, what is the interesting part of this decomposition is that using 2x2 general linear group matrix from a scattering matrix, we obtain a Hermitian factor which belongs to the Riemannian manifold of positive definite matrices, and due to that we are able to compute the distance between 2 points on this manifold according to this formula, and also by taking the geometrical mean over a set of points belonging to, for example, to one class or to one local neighborhood, we can compute the associated barycenter. And this computation is unique. The solution of this is unique. What can we do with this? We can propose a new algorithm which for PolSAR geometric classification. So it is a purely geometric classification where we start by the 2x2 scattering matrix, and then the first step is to apply the polar decomposition. We take into account only the Hermitian factor, and on this Hermitian factor we apply a geometrical k-mean classifier, which starts by first by filtering that we using Riemannian multilooking. What is Riemannian multilooking? Is very simple. Instead of using averaging when computing the complex multilooking, we take the barycenter, for example, in a 7x7 local sliding neighborhood, and we replace the speckle-free estimate with this barycenter. And then we apply on these results, we apply the Riemannian k-mean classifier. We with a random initialization, and then we compute the class centers using also the Riemannian barycenter, and we perform the class reassignment by inspecting all the pixels with respect to and comparing them with respect to the class centers using the Riemannian distance, and we assign the pixel to the class with a minimum distance. And then if we reach stop criterion, we have obtained our final classification. If not, we increase the number of iterations. So here are some results obtained with the same data set. And we need to look at the image 1 and image 2 and compare image 3 and image 4. So if we take a look at image 1 and image 2, image 1 is the first element S11 of the PolSAR scattering matrix. Its intensity in decibels. And image number 2 is the first element P11 of the Hermitian factor in the intensity in decibels, obtained within a 7x7 neighborhood by taking the Riemannian barycenter. And as we can observe, the information is preserved, and the estimation is a lot better using the correct metric, which in this space, which is the Riemannian distance, the Riemannian barycenter. This way, the estimate will be less influenced by outliers within this local neighborhood. Now, if we compare the classifications, we have the figure number 3, the results obtained with the proposed algorithm, and figure number 4, which is the result obtained using the geometric K-mean classifier with the standard covariance matrix. So we compute the sample covariance matrix using an initial 2x2 estimate, and then we apply a 7x7 complex multilooking, and then we perform classification. We notice very clearly that the algorithm which have presented today exhibits a lot better preservation of information, and also details are very well preserved. So this comes to my conclusion by adding also the fact that using the proposed coupling between polar decomposition and Riemannian K-mean, we are able to retain the initial resolution of the image. That is, no initial complex multilooking has to be applied in order to make this work. And I will end my presentation with some future work which involves the description or the characterizing the information which can be contained also on the unitary factor of the polar decomposition. Thank you for your attention. I will be happy to answer to any question.